Today's lesson is on symmetry. This would be something I've kind of dropped hints on in class about drawings being symmetrical and that sort of thing. So now we're actually going to classify types of symmetry and that sort of thing. Okay, so less graphs today and more just pictures. All right, the official definition of a symmetry is an isometry that maps the figure onto itself. So an isometry, this could be translations, it could be rotations, it could be reflections. All of those are isometries. So it just takes the figure and it maps it onto itself. Think of a shape that you can cut in half, fold in half, then both sides are equal. That's a reflection. So the first type of symmetry that we're going to talk about is reflectional symmetry, or called line symmetry, because you draw lines on the shape to show the lines of symmetry. So this is an isometry with the reflection of a plane figure. So how this works, if you took a hexagon and you're going to draw all the lines of symmetry of it, then we could draw a line of symmetry here. We could draw a line of symmetry here. We could draw one here. All of these lines, you could cut the shape in half on that line and have two equal halves. You could split the shape right down the middle, or through here, or through here. Any of those lines would be lines of symmetry where you could fold the shape and get it. So this would be 1, 2, 3, 4, 5, 6 lines of symmetry. Alright, how about a rectangle? So you could cut a rectangle right down the middle, if I could get it onto the middle. You could draw a line of symmetry this way. You could cut it both ways. However, with a rectangle, you can't draw a line of symmetry from corner to corner, because if you folded it corner to corner, the two sides wouldn't match up. So that's not a line of symmetry. So a rectangle only has 2 lines of symmetry instead of 4, like we think it should. All right, second type of symmetry is rotational symmetry. So this is a shape that can rotate and be the same shape again for some rotation of 180 degrees or less. So picture a star, or a hexagon, or a square. Those can all rotate however far, however many degrees, and you would get the same shape again. So if we take a square, let's draw a square. And let's say we go to rotate it. Then if I go 90 degrees, it's still the same square. If I go 180 degrees, it's still the same square. Okay? So any way you look at it, a square has rotational symmetry. All right. A specific type of rotational symmetry, and this is the third type of symmetry that we're going to talk about, is point symmetry. And this is 180 degree rotational symmetry. So if you have a shape that can rotate 180 degrees and still get the same shape, then it has rotational symmetry. Squares have this because they can go 180 degrees and you have the same square as what you started with. All right, so let's go through these. Does the triangle have rotational symmetry? So if I take this triangle and I spin it, will I get the same triangle? So let's try it. We take it and we spin it, and it should be the same triangle. And then we spin it again, should be the same triangle. The way I have it marked, it is an equilateral triangle. So it should be able to spin and be the same shape. Obviously, it's drawn a little crazy. Okay, so we're going to say yes, it does, because it's an equilateral triangle, so we're going to go with that. And then the angle of rotation. Picture how far it has to rotate before the corner ends up where another corner used to be. So it has to rotate this far. So remember yesterday we talked about, or 2 days ago I guess, we talked about how in the center of the triangle it makes a 360 degree if you go a full turn. So if you take 360 divided by 3, each of these are 120s. And so the angle of rotation is 120 degrees because that's how far it can go before you get the exact same triangle. All right, how about this triangle? This one's only isosceles. So if I take it and I rotate it, how far does it take before I get back to the same triangle? And now I'm back. I did a full turn. So I did 360 degrees to get a full turn. So it does not have rotational symmetry. So it doesn't have an angle of rotation. It takes that 360 degree. And every shape has 360 degree rotation, so that doesn't count. All right, how about this one? Let's say we take it and we rotate it. How far does it take before we get the same shape? That would be a 180 right there. And then 360. So it does have rotational symmetry because the angle of rotation is 180 degrees, and that counts. All right, so let's go through some regular objects. Does it have rotational symmetry about a line? So can I take a ping pong paddle and hold it and rotate it and get the same ping pong paddle if I go 180 degrees or less? And the answer would be yes. Because if you hold it on the handle and you rotate 180 degrees, I've got the same ping pong paddle. But I can't rotate it with the handle going around. It doesn't work that way. And then, does it have reflectional symmetry? Can I cut it in half? The answer is yes to that one as well. Because I can take it and cut it right down the handle in a couple different ways and have the same thing on both sides. All right, how about a coffee cup? Can I rotate it any way you look at it and have rotational symmetry for 180 degrees or less? And the answer is no for that. It takes 360 for it to get back to where it was. But does it have reflectional symmetry? Can I cut it in half and get the same thing? And the answer is yes. Think of the Alice in Wonderland Tea Party. He says just half a cup, half a cup. So he cuts it down the handle and gives him half a cup of coffee, and both sides are the same. All right, and the last one, an umbrella. And look at the handle of this umbrella. It does not have the little hook. It's just a straight handle. So does it have rotational symmetry? Absolutely yes. People spin their umbrellas all the time. And then does it have reflectional symmetry in a plane? Can I cut it straight down the middle and have two equal halves? And that answer would be yes, because it has a straight handle and not a curved handle. Okay, good luck.